right, today we're going to look at section 5.5, graphs of sine, cosine functions. All right, so we're going to look at putting these graphs on a coordinate plane and stretching it out two-dimensional and so forth. All right, so let's look at this unit circle again, and let's look at it as part of the Rapi function. Like here's a number line with some x values on it. And these would be negative x values. Suppose it wraps around there and so forth, okay? And let's look at pi over 4 is corresponding to this point here, pi over 2 corresponding to that point, 0, 1, and so forth, okay? And let's think about that. Now remember, in these ordered pairs of the unit circle, you have cosine and sine. And it's a theta or x or whatever, okay? So in other words, remember at 0 radians, your cosine is 0. At 0 radians, your sine is 0. At pi over 2 radians, your cosine is 0 and your sine is 1. So let's look at it as a function x and y. Y is equal to the sine of x. So I just picked some values of x right here. It doesn't really matter which ones you pick. I just picked some that came out nice and pretty. All right, so what I'm doing here is I'm going to try to plot y is equal to the sine of x on a coordinate plane. I'm trying to graph it, sketch the graph of it. Remember when you first learned how to sketch the graph of an equation, probably algebra 1 or something, you would pick values for x and calculate y. Pick values for x and calculate y. That's what we're going to start out doing here. I picked some values of x here, okay? And let's calculate y. Y is the sine of x. So when x is 0, what will the sine of 0 be? When x is 0, so when I rotate 0 radians, what is my sine? My sine is 0. How about whenever x is pi over 4? What happens if I input pi over 4 here? I get y is equal to the sine of pi over 4. So y will be what? If you rotate pi over 4 radians, what is your sine function? Square root of 2 over 2. So whenever x is pi over 4, y is square root of 2 over 2 here, which is about 0.7. I'm going to graph it, so I'm going to need to know about where it's at. How about whenever x is pi over 2? We have the sine of pi over 2, and the sine of pi over 2 is 1. And you can keep going around and doing this and doing this. I'm just going to fill in here, okay? This is square root of 2 over 2. At pi, your sine is 0. At 5 pi over 4, you're negative square root of 2 over 2. At 3 pi over 2, you're at negative 1. 7 pi over 4, you're at negative square root of 2 over 2. And at 2 pi, you are back at 0. Now verify those for yourself. Make sure you get the correct values in there. All right, so this is about approximately 0.7 as well. This is approximately negative 0.7, and this one's about negative 0.7 as well. Now let's graph this like we would x and y points on the coordinate plane. So let me draw a coordinate plane here, okay? Now this time on my x-axis, instead of drawing 1, 2, 3, 4, 5, I'm going to put like, say, pi here, and I'm going to put 2 pi there. Over here, maybe on this side, I'll put something like negative 2 pi, negative pi, and let's put on the y-axis a 1 here and a negative 1 down there. All right, let's plot points. When x is 0, y is 0, so I'm at the origin. How about when x is pi over 4? What is y? Well, about 0.7, right? So where's pi over 4? Well, this would be pi over 2, right? So halfway, I can go ahead, I guess, put pi over 2. Halfway between 0 and pi over 2 is pi over 4. And then we have a halfway mark between pi over 2 and pi. Let's go ahead and split this one up the same way. Let's put halfway between pi and 2 pi. What is 1.5 pi? Or 3 pi over 2, and then we'll just put some ticks in there, okay? We'll do the same thing over here. We'll say this is negative pi over 2. Put some tick marks here and here. We'll say this is negative 3 pi over 2. Put some tick marks here and here. All right, so I plotted 0, 0. Let's plot pi over 4, 0.7. Pi over 4 is here. 0.7 is about right here, right? We're kind of freehanding this. All right, how about pi over 2? At pi over 2, we're at 1. How about this point right here? That's what, 3/4 of a pi? Or 3 pi over 4? We're where? At 0.7 again? How about at pi? At pi, we're at 0. How about plotting my next point? 5 pi over 4. Well, look at how these are laid out. That's 1/4 of a pi, 2/4 of a pi, 3/4 of a pi, 4/4 of a pi, 5/4 of a pi. So 5/4 is here. So 5/4 I have negative 0.7 about. So 5/4 about negative 0.7. Then 3 pi over 2, I'm at negative 1. 7 pi over 4, where am I at? Negative 0.7. And at 2 pi, I'm at 0, okay? Now what happens if I connect these with a nice, smooth curve? And I can pick many more points to get this more accurate, my curve. But so far, can't seem to find the correct color I'm looking for, but oh well. We'll get something that looks like this. Let me adjust my point a little bit. Looks something like this. And actually, this thing keeps on going on. It keeps on going up and down and so forth, okay? And actually, if we pick points over here, we can come up with something that looks like this. It ends up having a point there, like a point here, and here, and so forth. And then this thing ends up looking like this. And so forth. All right. Last section, we talked about a period. Let's talk about a period. The sine function. This is the graph of y is equal to the sine of x. Now, I have a period that goes from here all the way to there. So it has a period of 2 pi, like we talked about in the last section. Also, let's notice this. It's a period of 2 pi. Doesn't that make sense where it's periodic, where it repeats itself? So what is the sine of pi over 2? It's up at 1, right? When else do you have a sine that is at 1? Not till you get over here, right? And that's a period of 2 pi. Kind of like here, you have a sine value that is 0, but where it starts repeating itself is over here, okay? So we say the period is 2 pi. So I guess I could write like this. I could say from here to right here as a period of 2 pi. All right, what we normally do is we normally talk about this first period right here, okay? We normally talk about from 0 to 2 pi, but we don't have to talk about that. That's normally what we talk about there. All right, so what is the domain of this function? The domain of this function, if it goes on forever in both directions, the domain's from negative infinity to infinity. And my range, read it from the graph. What's the minimum value of y it takes on? -1. The max is 1. But it includes those values. So we say from -1 to 1. All right, now, what I want to do next is I want to draw maybe just one period of this thing and label some important points on it, okay? Just because everything was so scrunched up here whenever I did that before. All right, so let's go ahead and see what this thing looks like. Let's say that this is -2 pi on the x-axis. This is pi. This is +2 pi. This is pi. That's the halfway marks in between there, okay? Here's 1 on the y-axis. Here's -1. What does one period look like if we start at 0? Looks like this. This, 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 And should have spaced that out a little better. Let's see. That should be about right here instead. And this. Okay, so that first period that we call looks something like this. Kind of hard to draw. Was an ugly drawing. Please look in your book or online for better drawings, okay? All right, so this is the point 0, 0. This is the point pi over 2 comma 1. This is the point pi comma 1. Not pi 1, pi comma 0. This is the point 3 pi over 2 comma negative 1. This is the point 2 pi comma 0 right here. I want you to be familiar with those points. Also want you to be familiar with the shape of it and so forth, okay? That's one period of it. Happens from 0 to 2 pi. And notice also your max point, your min point, and the x-intercepts is what I labeled there, okay? Now, what if we were to look at the cosine function? Cosine function, I'm not going to go through how we pick the points and so forth like we just did. I'm just going to draw it so I don't bore y'all to death here. All right, so let's look at y is equal to the cosine of x. Y is equal to the cosine of x. Let's see what this thing looks like. All right, so here's my x-axis. Here's my y-axis. Maybe let me use this. We'll go ahead and call that pi there. 1. My very unscientific measuring tool here. Go ahead and call that 2 pi. So 1, 2. We'll call negative pi. And then I'm going to have to extend this out. 1, 2. And we'll call that negative 2 pi. Okay? And let's go ahead and call this 1 up here. And we'll call this negative 1. And let's go ahead and put tick marks in here. Okay? All right. For your cosine function, it's going to start right here at 0, 1. Now it's going to go down through this point. It's going to have its lowest point at pi right here. It's going to go through this point, and it's going to have a peak point right here at 2 pi. And this graph's going to look something like this. It's going to go down like that, make a nice smooth curve, go through the x-axis there, and then it keeps going on forever. And a similar thing happens over here. Goes through this point, goes through this point, goes through this point, goes through this point, and it looks something like this. All right, what I want to do is I want to label these points, these maximums here, this minimum, and these x-intercepts on my cosine function. So this is at 2 pi, comma 1. This is at what? Let's think about that for a second. What's halfway between pi and 2 pi? 1.5 pi, or 3 pi over 2. This is at pi, comma negative 1. And this point is at pi over 2, comma 0. So whenever you think of the cosine function, I want you thinking of a curve that's shaped like that. And I want you thinking of these points right here. I want y'all to memorize that with it, okay? Now, it has a period from here to here as well. Remember we talked about the cosine function has a period of 2 pi as well? And let's list their domain and a range. What's the domain of this cosine function? Remember, it goes on forever. I just wanted to isolate this one period here. So that's a domain for negative infinity to infinity. And what is the range of this cosine function? From where? Negative 1 to 1, including both of those. Including both of those. All right, so we talked about the basic shape of the sine function, the basic shape of the cosine function. Now I want to talk about amplitude real quick, okay? Amplitude is defined to be the what? The difference in height right here. So in other words, 1 minus negative 1, or I could say 2, right? So what's the total height here? 1 unit, 1 unit, 2, and then divide that by 2, and that's the amplitude. So it's the total span right here divided by 2 is the amplitude. All right, next what I want to look at is the graphs of the sine and these cosine functions, maybe like shifted or altered or something like that. That's what we're going to look at in this section mostly. We have to know these basic forms to know what they look like. And then based off of that, we graph these other functions with shifts and so forth. All right, so let's write this down. Graphs of y is equal to a times the sine of x, and y is equal to a times the cosine. Actually, I need bx here instead of just x. Bx. All right, let's think about what this does right here. If there's some number here, it's going to be a vertical stretch or a vertical compression. Remember, if a is greater than 1, it's a vertical stretch. If a is between like, let's say 0 and 1, it's going to be like a half. It's going to be a vertical compression. And if a is negative, it's going to be a reflection across the x-axis. Okay, we'll get to that in just a minute. Don't worry about following real close with that right now. All right, bx. What does b do? B times x. That could be a horizontal compression or stretch, okay, depending on what b is. All right, let's see. Let's write some stuff down real quick. For y is equal to a times the sine of bx, and y is equal to a times the cosine of bx, and b is greater than 0, and capital B is greater than 0, the amplitude and period are the amplitude and period are, now they say are, I think of it like your book says are, I think of it as this is the way you find them. Amplitude you find by taking the absolute value of that number A, here or here, and your period you find by saying 2 pi over B. So that's 2 pi over whatever this number is being multiplied by x. All right, so memorize this, memorize this. We're going to use that a lot whenever we graph.